Hey everyone, so I'm Gabby, I'm one of your TAs this semester. I just wanted to make this quick video for you guys just to give you a little introduction to synthesis. I know it was covered in workshop this week, and I just wanted to give you a quick runaround in case you were sleeping or not paying too much attention or you just really didn't get it the first time. So this is just going to be a quick little video to give you guys some basics. It'll be covered more in the mega review and in office hours, so try to make it to those if you can. Alright, so let's get started. So for synthesis, you're given this toolbox. Now, this toolbox is provided to you on your exam, so you don't have to write it on your index card or anything. Don't waste that space. So the whole point of synthesis is to make a compound. When you're a chemist and you're in a lab, you're given this giant thing, right? It could be comprised of anything. Your goal as a chemist would be to break it down and isolate its pieces to find out what it's made of. So essentially that's what we're doing here when we're given large compounds. We're trying to break them down and find out what they're made of. Okay? So hopefully that makes sense. So what we're going to do is let's just review this toolbox real quick and then we'll take it from there. So the one key thing you want to realize with synthesis is anytime we're working with it, we're always given the product. Okay? So anytime you have something drawn, maybe it's like this, right? If the arrow is facing this way, that means that this guy is our product, okay? Once again, take a look at that arrowhead and where it's pointing. So this is BR, so BR is my product. So if I look here, I notice, okay, my arrowhead is pointing towards my BR, right? So those are related. So this guy's my product, this guy's my product, okay? As you go through each of these boxes, you notice that they're pretty straightforward. They can't really get you on any of this here. The one thing that's probably the most difficult is going to be box E, and really just getting the concept of working backwards, because that's essentially what we're doing for all of these problems that we have at hand. So for box A, what you're going to notice is that your product is a double bond, and you throw one of these guys on your arrow, and your double bond magically becomes a BR. That's right, these reactions are magic. You guys are not responsible for how they work just yet. As we go on in the course, you guys are going to learn the mechanisms behind them and get some more detail on how they work. But for right now, you just have to understand the concept and the basics of it. So for box B, all we have to notice is that our product is a bromine. We put HBr on our arrow and bromine magically becomes OH. Nothing happens to our carbon chain here. Everything remains the same. When we look at box C, we have H2PDC. H2PDC takes double bonds and makes them into single bonds. So if we were to go backward using box C, we would have to make our own double bond. Now for this reaction, you're able to add the double bond anywhere you like on your compound. There's no specific spot that's correct or incorrect. Next we have box D. In box D, we notice that our lithium's our product. When we put Li on the arrow, we go back to a bromine, and that's it. Carbon chains stay the same. Nothing crazy going on here. The only box that's a little tense is box E. So for box E, what you're going to notice is that we have 3 carbons in OH, 2 R groups. Now remember that an R group is anything that is not a hydrogen. So an R group could be just about any atom you could think of besides hydrogen. So for box E, we go from 3 carbons OH, 2 R groups to a double bonded oxygen attached to 1 carbon, 2 R groups, and then 2 carbons attached to a lithium. So box E is really the complicated step in all of synthesis, in my opinion. That's really where you guys seem to get the most lost. So this is where we're going to cut. So I'm just going to illustrate to you guys real quick using the example given in the box. And then we're going to do a few other synthesis together. In this video, I am going to be doing the synthesis from the workshop today. So if you had trouble with those, just keep watching, or if you need the answer for the last one. So the best way to approach this is to label everything. I think organic chemistry is best simplified when there's less thinking involved and it's more of a systematic approach. It makes it easier on your end. So the first thing we want to do is find our OH. Then I'm going to take this OH, I'm going to follow it with my finger across the screen. And on that carbon that the OH is connected to, I'm going to call that carbon B. Then I look at carbon B. Whatever carbon B is connected to, I'm going to call that carbon A. So I'm just going to label these A1, A2, and A3. Now for cutting, I'm only allowed to cut one carbon away. Now the reason I labeled this A and B because it simplifies things. Now I know for sure I can only cut between carbons A and B. I'll say that one more time. So we label carbon B, we label carbon A, and now we know we can only cut between carbons A and B. Now in this situation it could be any A or B. The reason why I am specifically choosing A1 and B is because in my toolbox it shows my lithium with 2 carbons. So I just want everything to be consistent. So now I draw my arrow. And the best way to go about this is to redraw this whole structure the way it is and then fix it in a minute. And you'll see exactly what I'm talking about here. So for this guy, I know that I have carbon B, carbon A, and I'm cutting in between. So that means that I know I am erasing this bond right here. So I'm just going to erase it. Now I have to figure out where my lithium and my double bonded oxygen are going. Well, now I have to think to myself, right? Because if I look at box E, I say, okay, I get a double bonded O and I get a lithium. Now what makes more sense? For my OH to magically become a double bonded oxygen, or for my OH to magically become a lithium? To become an oxygen, right? It's already an oxygen. Let's just get rid of the hydrogen and add a double bonded O. And for the purposes of right now, this is exactly what happens for you guys. We get rid of the hydrogen and we make that a double bonded O. So if this becomes my double bonded O, that means carbon A must get a lithium. Now when you draw the lithium in, make sure that you do not lose carbon A. It is still a carbon. You have to draw a line extending to the lithium. Okay? So that's just super quick cutting. We're going to apply it to real scenarios now from workshop. So we're going to do 3 workshop questions total, and then hopefully you guys will get this down pat, and we can move on with it. So let me see if I can do this. Here we go. Still getting a little used to this program. No. Okay, perfect. So let me put the other guy in. Add image. Not that one. This one. Okay. So now let's work with this guy. This guy was given in workshop as like a quick intro to cutting and all that good stuff. So as you can see here, they are clearly illustrating the A and the B cut that we just did, right? So they're taking the OH, right? And they're saying, okay, this is my OH, this is carbon B, this is A1, A2, A3. Now if I wanted to cut this, I have to cut between A and B. Let me just redraw this so it comes out a little cleaner on my end. There we go. So we're redrawing this, so now this is B, A1, A2, and A3. Doesn't matter how you do it here. But this whole carbon chain is 6 carbons. 1, 2, 3, 4, 5, 6, plus this guy is 7. We need to get it to 4 or less, so we have to cut. So I'm going to cut right here between A1 and B. Why? Because when I do that, this piece becomes 3 carbons, and this piece over here becomes 4 carbons, and I achieve 4 carbons or less, which is the goal. So now I'm going to draw my arrow. Anytime you draw this arrow and you are cutting, you must put 2.H2O under the arrow. That is worth 2 points on your exam. Don't lose that. That's easy points right there, okay? You guys want to make sure you keep those points. Why do you write 2H2O? Magic right now. You guys will find out why later. Just make sure it gets done. So now I'm going to redraw this guy because I know exactly where I'm cutting. Pencils are your best friend in this course. Definitely use them. Blah, blah, blah. Definitely use them as much as you can. So we're going to cut between A and B. Let me get my eraser here. We're going to erase this bond. And we know that the OH is going to become that double bonded oxygen. And we know that A is going to draw a bond, and we are going to have lithium attached, and that's it. That's cutting. If you stick to this convention where the carbon attached to your OH is B and 1 carbon away is A, you will you will always end up with your B carbon containing the double bonded oxygen and your A carbon containing the lithium. Alright guys, let's move on to the next problem from workshop and get this stuff done. So hopefully you're following along nicely. If you're going to watch this video, at the end of it, if you still find that you are confused, please come to the Chem Learning Center. There are a ton of TAs who want to help you, who want to take care of you. Oh no. I don't know what I just did. Oh, okay. I have no idea what that was. Let's see if I can make this image a little bigger. Like I said, still working out the kinks. Oh, here we go. Perfect. All right, so let's do this guy next. This was question 4 on the workshop. So the whole point of this question was to get to 4 carbons or less. So the first things first, this guy is our product. It's our product. How do we know that? My arrowhead is facing this bromine, the same way this arrowhead is facing that bromine. That's how I know this dude is my product. So from here, I go to box B, and I say, okay, here's my bromine, which is a product. I notice that my bromine, which has 3 carbons here, magically becomes an OH, which still has 3 carbons, when I put HBr on the arrow. So all I'm going to do is put HBr on my arrow. Then I'm going to draw however many carbons I have, which is a lot, because here the carbons don't change, so here the carbons will not change. Then my Br magically becomes an OH. Woohoo! Now I see an OH and I go, oh snap, that's the cut step. Once we see OH, we cut. So we know we got to use box E. Now this is that guy that we just did. So we're going to go to my OH. I'm going to trace it with my finger. The carbon it's connected to is going to be carbon B. Then, one away from B on either side is going to be carbon A1, carbon A2. Now, I need this guy to be 4 carbons or less. So if I cut right here on this green dotted line, this piece becomes 4 carbons, and this piece becomes 4 carbons. That sounds pretty good to me. Let's see what were to happen if I cut on the other side instead. If I cut between B and A2, this piece is now 5 carbons. This piece is now 3 carbons. Now, technically, we could cut there and get a 5 carbon piece. However, if we were to do that, we find that we back ourselves into a hole. Because now I have a 5 carbon piece with a double bonded O and no way to work with that double bonded oxygen. So we're going to avoid that scenario for right now. So we're going to cut between A1 and B. Okay? Now remember, this first step, my HBr step, to backtrack for just a moment, I chose HBr because bromine is a product. In A and D, bromine is a reactant, so it will not work. I have to use B, where bromine is a product. Okay? So now I get my cut step. I draw my arrow, and what's the number one thing that's got to go underneath? 2.H2O. Get those 2 points in. Be happy about it. Call it a good frickin' day. Get you 2 points. Now, to make my life nice, easy peasy, lemony squeezy, I'm going to redraw this exact structure and just erase. Because I'm a lazy person. I don't like thinking. I don't like losing carbons. I like to keep things nice and simple. So I got A and I got B. I'm going to erase where I am cutting right here. All right. Now I am going to go to carbon B, erase that H, make it a double bonded oxygen. Then I'm going to go to carbon A, and I'm going to draw a bond and then connect my lithium to it. The lithium's connected to carbon A. Don't confuse it connecting to the other structure. Let me see if I can draw that a little nicer for you guys. Give me 1 second. So I get the lithium connecting to carbon A, and then this guy was the double bonded O. Alright, so that's pretty much cutting in a nutshell. After you guys do it a few times, it should become second nature. Both pieces here are 4 carbons, so we're good to go. I can move on. On an exam, if this were your synthesis and you did it exactly like this, you would receive a 10 out of 10. Okay? Synthesis is going to be on every exam from now until the end of Orgo 2, and it will always be 10 points. So make sure you guys are aware of what we're doing here, okay? And what we got going on. Now, let's put the next synthesis in. This one I'm sure most of you did on your own if there wasn't enough time. So let's work on this one together real quick. Let's move him over here. This one's a little lengthy. It mainly has to do with repetition. That was the whole point of it. We want you guys to practice doing this, and we want you to get good at it. So now, looking at this, we notice, okay, my arrowhead is pointed in this direction, right? So it's pointing to the OH, which means that my OH is my product. Where is the only box where OH is a product? That's going to be box E. That's my cut step. So the first thing I'm going to do before I do anything else is draw 2.H2O on the bottom of my arrow. Okay, that is my first step, no matter what. 2.H2O. Now for this synthesis, they also want 4 carbons or less. So now I'm going to go to my OH, trace it with my finger to the carbon it's connected to, that's B. 1 carbon away, A1, A2. And now I think to myself, okay, if I cut on the left-hand side between A1 and B, I will end up with 3 carbons over here, a shit ton over here. If I cut there, I get a double bonded oxygen. I cannot work with that oxygen. We just said that in the last problem. So I have no choice but to cut between B and A2. When I cut between B and A2, I get, oh no, there we go. I get 4 carbons over here and a shit ton over here, but these guys don't have the double bonded O, so we are safe. Remember, the reason why we can't have a double bonded O and have to work backwards more is because I don't have a double bonded O as a product in my toolbox, at least not yet. Okay, so I'm going to redraw this whole structure. Make sure when you are redrawing, you are counting your carbons. If you have to physically count them out, do it. Don't lose points because you can't count carbons, okay? I want you guys to get all the points. I want you all to get A's. I want you all to kick some ass. So we get, where am I? B and then A. We're cutting between these guys. The OH goes away. We get our double bonded oxygen. Then carbon A gets the lithium directly attached to it. So we go bond, lithium. Okay, that's an Li. Now we notice this guy with the double bonded oxygen is 4 carbons. We check that off. This guy still has too many, so I have to cut again. Now don't just start cutting. Remember, we're going backwards. Draw your arrow backwards. If your arrow switches directions, make sure you catch yourself, okay? You're going to lose some points there. Remember, we want all the points. So now I have a lithium as a product. In which box do I have lithium as a product? In box D. So box D tells me put a lithium on the arrow, draw the carbon chain exactly how we see it. Lithium magically becomes a Br. Now all I did here was I drew my Br down instead of up like the lithium. Do not let that throw you off. I just rewrote it a different way, okay? Now Br becomes OH. How do I make Br into OH? We use box B. This is still my product, so I still have to look at the product side. So box B, I use HBr, and the Br magically becomes an OH. Now I can cut again. So I go ahead, I go to OH, follow it with my finger. That carbon's B, next one's A. Those are the only carbons attached, so those are the ones I must cut between. I have no other choice here. I am stuck. So I cut between B and A. I draw my arrow. What's the first thing that goes under that arrow? 2.H2O, get my 2 points. I redraw this whole structure over. I got B and I've got A. I now can cut. I take my OH and it becomes a double bonded oxygen, making sure that I get rid of that hydrogen. Don't forget to get rid of it. Then I go to carbon A and I create a line and I attach my lithium. Okay? Now mine's kind of cramped. Make sure yours is spaced out and that it looks pretty. This one looks pretty ugly right now. Now, what do I notice about my lithium? Oh no, okay. My lithium still has 1, 2, 3, 4, 5 carbons attached, so I have to go again. The double bonded oxygen only has 1 carbon, so that's good. Now, I draw another backwards arrow, make sure it's not going forwards, make sure we're going backwards. And I put Li on the arrow. My lithium becomes a Br. Again, just writing it a different way, don't be confused. Oh, good, my lithium becomes a Br, right? Okay, lithium becomes a Br. Then I use HBr. My Br becomes an OH. You guys feeling repetitive yet? I'm getting a little repetitive over here. Go to your OH, follow it to the carbon, that's B. A1, A2. We cut between A and B right here, right? Because now this piece is 2 carbons, this piece is 3 carbons. And finally, this is our last cut. We made it to the finish line. I draw my arrow directly underneath, goes 2H2O. Redraw this guy. I have B and A. I erase that bond between them. I make my OH into my double bonded oxygen on carbon B. And then on carbon A, I add a bond and I get my lithium. So now I am 4 carbons or less. All of this looks great. On an exam, I would get 10 out of 10. And then you're happy because you got all the points. All the points. Okay, some quick notes. Really quick things. So something you want to notice here is the way I drew my arrow. So you notice how I have 2 H2O, but I have nothing on top. That's okay. So in the example, box E, they put a double bonded O number 1. In your synthesis, you make your own double bonded O. So you don't want to put theirs when yours is already right here. That's going to get points off. Remember, you're making your own double bonded O, so you don't want to put theirs and yours. Now, are you forced to put something on top of this arrow? Hell no. You do not have to put 1 dot and then put this guy. It is totally okay if he stays on the side. If you want to put him on the arrow, that's perfectly okay. Just only put him on the arrow. Don't put him here. You are also allowed to put your lithium structure on your arrow. It's too many carbons, but you could also put that guy on top. That's perfectly fine. So you have a lot of wiggle room here in terms of what can go on the arrow and what can't. Make sure this guy is always there. That's 2 points. So that's 2, 4, 6 points just in 2.H2O. No brainer, right? So keep that guy there so that way you get your 2 points, all right? So once again, anything can go on top of the arrow. It's really up to you. I don't like to put things on the arrow. I like to play it safe. I don't want to miss numbering at number 1. And yeah, so make sure you guys go to the CLC, get all the extra help you need, ask questions in workshop, all that good stuff, and happy studying.